So let's look at some examples with our projections. Projections are used in physics in calculating work. Work done is defined by constant force F in moving an object through a distance d as work equals force times distance. But this applies only when the force is directed along the line of motion of the object. That means if we're trying to move it along the line PQ, our force has to be parallel to that vector going in the same direction. So suppose that a constant force is vector F, in our picture here, vector PR, pointing in some other direction. If the force moves the object from P to Q, then the displacement vector is D, and D is going to be equal to our vector PQ. The work done by this force is defined by the product of the component of the force along vector D and the distance moved. So work equals, now we have to take our force and multiply it by the cosine of theta, and then multiply it to our magnitude of the distance that we traveled. So there's our formula. Now, if you don't have theta, you don't know what it is, then you can use this formula. You just take the force vector and the displacement vector, or sometimes called the distance vector. When you have those in component form, you just find the dot product, and then you find the amount of work done. So, example time. An object is pulled 10 feet across the floor using a force of 85 pounds. The direction of the force vector is 60 degrees from the horizontal. Find the work done. Okay, so they gave us theta, and we can just use this part of the formula right here. So here's my picture, there's my object. We're moving it across the floor. My force is going 60 degrees upward. And what's in red is going to be, that projection is going to be how far my object has moved. So if my force vector, that would be the 85 pounds, so I put out my 85 pounds on my vector here, it will move it, the red vector, along that displacement vector D. So using our formula here, we'll go 85 pounds times the 10 feet times cosine of 60 degrees, because we moved it 10 feet, that's the red vector. Multiply that out, cosine of 60 degrees is 1/2. The amount of work done is 425 foot-pounds. Example 8, a force in newtons is given by F equals 3I plus 4J plus 5K. Those are our standard basis form of a vector, so we can put that in a component form, 3, 4, 5, and moves a particle from point P at 210 to Q, 462 in meters. Find the work done. So there's my component vector. Now, my vector D is P to Q. So 4 minus 2, 6 minus 1, 2 minus 0. That component vector is 252 in meters. So here you just have to do the dot product. So 3 times 2, 4 times the 5, 5 times the 2, 6 plus 20 plus 10, we're at 36 Newton meters. And Newton meters are also converted into joules. All right, so there's our examples of our